we're talking about the remainder theorem. Before I jump into the remainder theorem, which will be very quick and it involves synthetic division, let's talk about this. I give you a function, the function that's at the top there, x to the fourth plus 3x cubed minus 17x squared plus 2x minus 7. And I ask you to find f of negative 1. All right, what you would normally do for f of negative 1, you would take negative 1 and you would plug it in for every x that is involved. It's a lot of x's in this case. All right, if we're doing the steps, we can obviously type this in our calculator, but it's no big deal by hand either. We get 1, we end up getting a minus a 3, we get a minus a 17, minus a 2, minus a 7. So we get a negative 2, we get a negative 2, minus 17, minus 2, minus 7, negative 19, minus 2, minus 7, negative 21, minus 7, and then negative 28 is my final answer. All right, doing that in our head, doing it on the calculator takes a little bit of time. The remainder theorem can potentially cut out some time for us. All right, so what the remainder theorem says, when we divide f of x by x minus k, the remainder is f of k. So whatever you get when you plug in k, you're getting f of k out, obviously. So what I'm getting at here is when you divide, or when you send, like if same function, I ask you to find f of 3. What you can do is take that 3, plug it in there, run it through synthetic division, get it all set up, run it through synthetic. 3 times 1 is 3, 3 plus 3 is 6, 3 times 6 is 18, we get 1, we get 3, we get 5, we get 15, and then we get 8. The remainder is your answer. So f of 3 equals 8. In my opinion, if you remember to use synthetic division, if you remember about the remainder theorem, it's actually easier than plugging stuff in. It takes less time than doing it in your calculator even. There's less room for error when you're just adding or subtracting. Checking out one more, if I asked you to find f of negative 2, you would take negative 2, put it outside the box. We're plugging in the same numbers, the same functions, with the same coefficients. Drop it down. Negative 2 times 1 is negative 2. 1, negative 2, negative 19. We get 38. We get 40. We get negative 80. We get negative 87. That would be your answer. So if I take negative 2 and I plug it into that function up top, I'd get negative 87 out. I personally don't want to deal with like 3 to the fourth, negative 2 cubed, stuff like that. There's more room for error with calculators, doing in your head, all that kind of stuff, versus synthetic division here. So this is the remainder theorem. So if I ask you on the worksheet to find f of whatever number, just take that number, run it through synthetic, and that'll be it. Your remainder is your answer.